When we talk about adding and subtracting functions, you're going to need paper because it's just like the textbook pages, so yeah. So it says you can add two functions, f of x and g of x, to form the combined function h of x equals f of x plus g of x. If it's written like this, we will rewrite it as h of x equals f of x plus g of x. That is how we will rewrite it. You can subtract two functions, f of x and g of x, to form the combined function h of x equals f minus g. And we would rewrite this as f of x minus g of x. The domain of the combined functions form the sum or difference of two functions. So the only way that you can actually add or subtract functions is if they exist in the same domain. So if I'm looking at f and g, do you see this here? G, or f, I guess, is less than or equal to 3, and g is greater than or equal to negative 5. But when I combine their two functions together, I can only combine where they both exist. And do you see how they both exist between here and here? So that's how we get this graph here, the combined function. So the domain for adding, subtracting functions can only be where they both exist. Okay. So we're going to talk down here first. So here it says for each pair of the functions, we want h of x. And h of x is just f plus g of x. So on a separate sheet of paper, we're going to do that. 1a, h of x equals f of x plus g of x. Now, if I reorder them and I do g of x plus f of x, am I going to get a different equation? Me staring your phone away. Where's it going to go? Where's it going to go? Make it disappear. Oh, all right. So f of x plus g of x plus f of x, same graph, right? But if I subtract them, will I get the same graph? F minus g, g minus f, then it's different. So you have to really watch the order when it's subtraction. Okay. So we're going to go h of x equals the absolute value of x minus 3 plus 4. I don't know why I just put a bracket. Okay, where the errors happen is you guys don't know how to simplify terms. And you often simplify things you can't simplify. So this is the absolute value of x minus 3 plus 4. Can I put the 4 with the absolute value? No, this is done. But we're going to talk about the domain and range. So the domain of x, the absolute value of x minus 3, the absolute value of x minus 3 looks like a graph like this. What's its domain going to be? X is an element of the reals. Exactly. And g of x is a line at y equals 4. So it looks like this. What's its domain? XER. So where do they both exist? In the domain what? Everywhere. That one exists everywhere, this one exists everywhere. So when I combine them together by addition, their domain is going to be x such that x and l are the reals. On a diploma, can I put a D and expect they know that's domain?
No.
No.
Right domain.
No short form.
Wait, so isn't it only multiple choice on the diploma?
Pardon?
Is there a written response?
Yep. There's 24 multiple choice, 8 numeric response, 3 written. Each worth 5 marks. That's 25% of your test. Okay, B. H of x. H of x equals 3x minus 5. So f plus g, which is negative x plus 2. So that's me adding the two functions. Is there anything I can do? Clarify terms. Yep. I just started like something got mumbly and I didn't. So h of x equals 2x minus 3 is true. That's a linear line, and I know that that's domain is going to be XCR. We agree? But let's prove it by the other pieces. So the first graph is f is 3x minus 5. So we have negative 5, we go up 3 over 1, and we have a graph that looks something like this. Okay? What's its domain? XER. Then the next one is a line at y equals 2, down 1, right 1. So it looks like this. What's its domain? So its G domain is XER. So the combined domain is what? Where they both exist, which is XER, right? And we proved it, because when we put the function together, we got a line which had XER. So we won't do domain for the rest of them, we'll just put them together. But we will be doing domain when we get to number 4, so it's fine. I just wanted to prove to you that we didn't actually have to find the new function. If they just ask us for the domain of the combined functions, we can just find the domain of the two of them and where they both exist. Okay, I want you guys to do C and D. Give me the two new equations. Just the equations, I don't need the domain or range, just the new equation. H of x.
In the olden days, in the 1900s.
True that. Okay, h of x, we have x squared plus 2x plus x squared plus x plus 2. When we add the two functions, and what do we end up with, guys? It was well done. Perfectly executed. Okay, D. D is where people are going to make oopsies. We don't want any oopsies. I hope you didn't make any. So h of x equals negative x minus 5 plus x plus 3 squared. Okay? Now the key thing is there are two of them. So if you do this, a lot of people will say x squared plus 9. That's not actually the full thing. It's going to be x plus 3 times x plus 3. So it's x squared plus 6x plus 9, and you forget the middle term. So h of x equals negative x minus 5 plus x squared plus, this board is really making me happy, plus 6x plus 9. H of x equals x squared plus 5x plus 4. Even this board wants a Christmas holiday. Yeah? Okay, what's the difference in number 2? There's a minus sign. So we have to remember to minus all of g of x. So let's go to 2a. 2a is h of x equals f of x minus g of x. And for a, f of x is 6x. Minus g of x. G of x is x minus 2. So if we minus x minus 2, what do we actually get? Negative x plus 2. Exactly. And so our resultant equation will be 5x plus 2. Okay, you guys do BPD, go. B, we have to do f minus g. We can't do g minus f. We don't get an option. So h of x equals negative 3x plus 7. And then we have to minus all of g. So minus 3x squared minus x plus 2. And so we get negative 3x squared minus 4x plus 9. And then C, we get h of x equals f, which is 6 minus x minus x plus 1 squared minus 7, minus that whole thing. And so we're going to get h of x equals 6 minus x minus x squared plus 2x plus 1 minus 7. And so we get h of x equals 6 minus x squared minus 2x minus 1 plus 7. So we get negative x squared minus 3x plus 12. And 4 part is annoying. And then D, we just get cos x minus 4. Yep. 1x plus 1x. X plus 1 squared. Is x plus 1 times x plus 1, which is x squared plus 2x plus 1. Right? Yeah.
Yep.
Now this one, is this a horizontal phase shift 4 to the right, or is that a vertical displacement 4 down?
Vertical displacement.
Vertical displacement. Some people are like, but I put brackets. Okay, but you put brackets, right? If you want to put brackets, you can, but you have to put them around the x then. So it's still a vertical displacement 4 down, right? All right, we're going to look at number 3. Number 3 can be done one of 2 ways. I'm going to show you the 2 ways, and then you'll be able to pick which way you like for B and C. Okay? Everyone's watching. So it has consider f of x equals negative 6x plus 1 and g of x equals x squared. And they want to determine h of x equals f of x plus gx, and then find h of 2. Okay? So the first way we can do it is actually to just find h of x, which is f of x plus g of x. So we're going to get h of x equals negative 6x plus 1 plus x squared. And now we have, now we have h of x, correct? And they want h of 2. So we're going to get negative 6 times 2 plus 1 plus 2 squared. So h of 2 equals negative 12 plus 5. So h of 2 equals negative 7. And this is the answer. Negative 7 is the answer. But we really did just find a coordinate on h of x, didn't we? We just found the coordinate 2 and negative 7 on h of x. That's all we did. So that's one way we could do it. We could literally find out what h of x is first, then plug in the 2, correct? Or we could plug in the 2 first. So we could go h of 2 equals f of 2 plus g of 2. You see how I plugged the 2 in right away? We do that. If we do that, off to the side we have to find f of 2 and g of 2. So f of 2 equals negative 6 times 2 plus 1, which is negative 11. And then g of 2 equals 2 squared, which is 4. And so h of 2 equals 11, negative 11 plus 4. So h of 2 equals negative 7. Same answer, right? So really when they're asking for h of 2, they're asking for the y on the graph of h of x when it's x is 2. Yeah? Okay, both those answers are correct. Neither one is better than the other, except for in your mind. One of them is better than the other. I just don't know which one that is. But you can do it whichever way you want, right? Same answer. So do B and C. Go. B has m of x. Come on, write the letters, board. M of x equals negative 6x plus 1 minus x squared. Anger level's getting higher. M of 1 equals negative 6 times 1 plus 1 minus 1 squared. What'd you guys get?
Negative 6.
You are right.
I just thought there's a typo in here. It says practice. Yeah, is that like the way it's spelled?
Where is this?
It seems a little nice spelled.
Definitely. No. Where do you even see that?
Where are you seeing this?
Above one. Above one. Below, check your understanding.
Practice?
Or maybe we're just not smart and if that's how you spell it.
This is the textbook in Alberta.
S or a C?
I seriously don't see it. I can't even find the
That's
word.
not right.
It's absolutely how you spell practice.
Yeah, it's with an S.
That is absolutely.
I'm glad that that is something you guys actually read, but you guys bypassed my instructions on the test.
Okay, Miss Lepp. So,
You're
gonna spell it all wrong.
practice.
Okay.
It's not.
And this one is P of 1 is what? Positive 6?
Yeah.
Okay. We're going to go to 4.
CC is positive 6.
Okay.
Yes, we know.
Let's practice, guys.
Okay, I have to remove the
Okay.
word from this one.
So, we need all the brain matter for this next question. So, 4A is y equals f plus g of x, which is the same as f of x plus g of x. They want determine the combined function and its domain. Before we do its domain, let's talk about each function's domain separately. So f of x, everyone's paying attention? F of x has its equation is 3x squared plus 2. It is a quadratic. What is its domain? Element of the reals. All right. Then we have g of x. G of x is a radical. Square root of x plus 4. What is its domain? What is? What's underneath here is greater than or equal to 0. Greater than or equal to, because what's underneath this radical has to be greater than, but it can also be equal to 0, correct? It just can't be negative. Everyone's watching. So our domain is going to be x is greater than or equal to negative 4. So where is the most restricted domain in these two domains? XER or greater than or equal to negative 4? This is the only place where they are both going to exist. We agree? Yeah. So the domain of this combined function, that domain is going to be, without even doing the question, x such that x is greater than or equal to negative 4. X is an element of the reals. I could do the domain of this question without ever finding the function out. Because it's where the two combined domains exist. Okay? Let's actually get the question though. So it's going to be y equals 3x squared plus 2 plus the square root x plus 4. And then people try and simplify this. There is nothing you can simplify. But I do want you to type that into y equals, please. Everyone go type into y equals. Right, meow.
Wow, sorry.
Y equals 3x squared plus 2 plus square root x plus 4. And I told you that the domain of the combined function should be greater than or equal to negative 4. When people go and put it right into their y equals in their calculator and they press graph, they think that it exists everywhere. What you need to do is you need to increase your y maximum because you guys aren't seeing the graph to negative 4. You're seeing it up to a certain amount. So go to your y max and make it be 30. So can you see that it starts at 4? Negative 4? Yeah. So, nope, go higher. Window. Make your y max be 50 then. Oh, make it a little higher. Make your y max be 60. Yeah. Now you can see,
Oh, what the heck?
if you make your y max be 60, you can see that it starts at negative 4.
Dolphin? I don't know, there's like a dolphin right behind me.
Oh, okay.
Like it just.
It's a dolphin.
Yeah, the dolphin just swam by the name of Chad.
Oh, yeah.
All right,
Sponge out of water.
B, we gotta get through these.
That's crazy.
So B is y equals h minus g of x. So y equals h of x minus g of x. Before I even do this, I'm going to write my h of x over here. So my h of x equals 4x minus 2. What's its domain? It's a line. round in the reals. It's a polynomial. All polynomials round in the reals unless it's a word problem. Okay, then we have to do g of x. G of x is root x plus 4. What's its domain? X such that?
X is greater than
Yeah. What is the most restricted domain out of these two? This one. So that is going to be the domain of our combined function. And then when we find our function, we're going to get y equals 4x minus 2 minus square root x plus 4. C. So we're going to look at C. C has y equals g of x minus h of x. It's going to have the same combined domain, correct? Because they're the same functions, just in opposite order, right? So its restricted domain is going to be the same. And we're going to get y equals square root x plus 4 minus 4x minus a minus 2, so plus 2. And that'll be our C. Our D is y equals f of x plus h of x. F and h, F is a quadratic, H is a linear. What's their domain combined going to be? XER. That is not supposed to be here. That goes to this one. This one is going to be x such that x is the noun of the reals. They both are x the noun of the reals. So if I ask you for the domain of a combined function when I add and subtract functions, do I actually have to put the function together? Or can I just find their two combined functions?
Just find the two combined
Function domains. Yeah.
function domains.
So f of x is 3x squared plus 2 plus 4x minus 2. Like terms, those cancel. And I'm left with 3x squared plus 4x. Thanks, Lord. So, on Friday we're going to finish this up and then we're going to start multiplying and dividing. We have 2 lessons left after this.
One time flies.
What are all the other?
Oh, I missed it! All right, pause it.
Young people